Right, hi everyone. Thanks for joining my talk. The talk is all about VLAN hopping using just SNMP. So I apologise to anyone who thought the talk was about frogs, because it isn't. It's quite a technical talk. So quick intro about myself. I am Daniel Compton. I work as a principal security consultant at InfoAssure. So I'm a check team leader, so I conduct many pen tests, IT health checks, see many data centres. Like I'm sure most of you, if you're pen testers, will see. Quite an interest in security bug finding. There's quite a few CVEs, acknowledgements for various bugs are found. And the most recent was a privilege escalation in an HP switch. There's also quite a few pen testing tools that I've created, sort of aid the use of pen testing and VLAN hopping. You can get those on my blog and also on the InfoAssure website. So what this talk will cover: current VLAN hopping limitations, SNMP VLAN extraction and hopping techniques, multiple VLAN hopping demos. A bit crazy because some of these, well, they're all going to be live demos, so hopefully they work. And a release of my new tool, which is called Frogger 2. Anyone that's used Frogger before for VLAN hopping, this has got a lot of new enhancements that I'll go through, and is the reason you'll see a lot of frogs in the slides. So the current limitations with DTP attacks are that it's port specific. If you don't know what DTP is, it's the Cisco dynamic trunking protocol that handles trunk ports, and you can basically attack that and VLAN hop effectively. The important thing to note with DTP is that it is port specific. So if you plug it into a port like shown up here, if you can see that, this is an access port, so it's not broadcasting any DTP packets, and it's locked into VLAN 50. So this is the port config on the Cisco device itself. So the issue here is, so basically with that port configuration, you wouldn't be able to VLAN hop using the DTP attacks. So the issue here is, unless you're reviewing the whole switch config as well, you wouldn't be aware of the settings for other ports because it's port specific. So without the actual switch config, you'd have to plug into every single port on the switch and see the mode of DTP to see if you can VLAN hop, basically. So you can't just test one port. It could be any port on the switch. So using SNMP, you can extract really useful VLAN information. You can even VLAN hop without the need for DTP at all, which is the main sort of focus of this talk. The great advantage with this method is you can actually alter any port on the switch, so not just the port you're connected to. So with DTP, you can only attack the port you're actually in at that time. If you can get SNMP writable strings, you can attack any port on the switch. You can also make the port into a trunk, just like with a traditional DTP attack, or you can actually just pick a VLAN ID that you wish and just enter that without the need for becoming a trunk. So if you want to go into VLAN 44, you could just jump into that VLAN. You don't have to make it a trunk port. So, for example, if you just want to enter VLAN 44, you don't have to touch anything else on the switch. You can do exactly that. So just quickly comparing the two VLAN attacks. So the traditional DTP attack and using SNMP. So with DTP attacks, you don't need an IP address on the attacker system. So on your laptop, you don't need an IP address. It's completely layer 2. You just run a DTP attack, and it works. This is the traditional attack method. The issue with this is, if DTP is off or in a different mode, it won't work. So you'll just say VLAN hopping is not possible, and that's it. With SNMP attacks, you must have an IP address and a writable community string. So you do need those two things in order for this to work, which won't always be the case, but it's an alternative method. Again, with DTP, you can only attack the port you're connected to. With SNMP, you can attack any port, any VLAN, and even set any DTP mode you wish. So many tests these days have very specific goals or scopes relating to segregation of VLANs. So for example, many of our tests, the customer will just say, can you access the management VLAN from the accounts VLAN? Occasionally we still find DTP enabled where we can do that, but we can't count on this as being the only avenue for attack. What we do still see a lot of amazingly, it's default SNMP community strings. So perhaps the devices aren't configured fully ready for the pen test, which is quite often the case, or they could have just been overlooked, but we still see this a lot. So if the main focus of the test was to VLAN hop, and we can't do this through DTP, but we say to the client, we found some SNMP issues, they probably won't be that concerned. But with default or weak writable SNMP community strings, we can actually succeed on the main goal for the test, and we can actually then VLAN hop and compromise the management VLAN effectively. So this is where DTP wouldn't work. We can then jump into there. So the client's obviously going to be more concerned about this than just say we found some SNMP issues. So we then probably have unrestricted network access from that port. So traditionally, typically on a pen test where you found read-only SNMP, you'd probably extract something like this from the switch just to put in your report as evidence. More than likely, you would just move on. Wouldn't do too much with that. If you find writable SNMP, if you're lucky, you can pull back the Cisco config, maybe crack some passwords. But that tends to be about as exciting as it gets on a test with SNMP. Excuse me. So even if we just have read-only SNMP access, we can extract some really useful VLAN information. There's some really useful SNMP MIBs and OIDs to get back the VLAN information and DTP information from the device. It must be the Cisco device. So using the example SNMP query, we can get back some quite useful information. It's a very simple query. It's basically just querying the device here with a read-only community string, just using SNMP walk. That's just the OID from the MIB. Just a bit of cutting and pasting around. Then we can get back all the VLAN IDs and names. So this is just using read-only access. But that's a bit nicer to put in a report for a pen test than just a load of OIDs and sort of not very useful information. You can see there's a 44con VLAN there and also various other ones. So that's really useful information if you're planning any attacks on the network. With read-only access, obviously you can't VLAN hop because we need to write to the device, but the information you get back is pretty good. Some of the information you need to get back gets a little bit more complex, and you need to use multiple SNMP OIDs to find the port you're in and then find the VLAN that you're connected to. So you can't just run one SNMP query. It gets a little bit more involved. You have to run multiples. So why do you need to know what port or VLAN you're connected to? So, well, for SNMP VLAN hopping, we need this information to alter your port configuration. Because it's not a DTP attack, it works a bit differently. So you won't always be looking at the switch in a data center. You could just be at a desk with a cable, and you might not have any knowledge of what VLAN that's in or where it goes. So quite often you just sat at a desk in an office testing. You wouldn't see the switch. For VLAN information extraction, we need to know what port you're in to then find the VLAN number and then obtain the port config. So we have to use various OIDs to do that. Unfortunately, when I was sort of doing this research, I found quite a few complications when you start extracting the VLAN information from the Cisco boxes. So some of the Cisco OIDs behave quite differently, which is quite strange, and I don't know why. But depending on what VLAN you're connected to, they respond differently. So for instance, if you're in the native VLAN 1, the example query will respond with your MAC address, as it should. So if you look here, I'm just running a basic query. This is on VLAN 1. There's a read-only community string. I'm just running this OID. And what we get back is our MAC address of our local laptop. So we know we're plugged into there. The issue is, if you're not in the native VLAN, the OID responds differently. So if we run exactly the same query, an interface we can connect to, which is in VLAN 50, we get no such OID at this address. So that it complicates things quite a bit. And it's all because we're not in the native VLAN. So it does sort of stop us in our tracks because it's quite unlikely on a pen test you won't be in the native VLAN. Usually you're given sort of 10 or so VLANs to test, And so this wouldn't work. So where it works before, if you're not in VLAN 1, it will fail. So that's quite a pain. So it gets around this issue. I've kind of played around and worked out what you have to do. So what you have to do is add the VLAN ID to the SNMP query. So we have to add, this is the community string here, public. We have to add @50, which is the VLAN ID, to the original query, and then it responds, which is great. So the only difference between those two is I'm adding @50, and then it works, which is handy. So again, there's our MAC address. The issue here is we might not know what VLAN we're in. So we could just be plugged into a port, so we wouldn't know it was @50. So basically what we have to do is cycle through all the known VLAN IDs that we previously extracted and feed them into the query. So if you see here, when we try VLAN 44, no such instance. We try VLAN 50, and again, that works. So we know we're in VLAN 50. So this is why we need to know what VLAN we're in. So we have to first extract all the VLAN IDs and then sort of loop them and feed them into the query. Because you probably won't know what port VLAN you're in. That's the issue. So luckily it does vary between the OIDs. So luckily the first SNMP OID we use to extract works no matter what VLAN you're in. So no matter what VLAN you're in, you can run this query. You don't have to add any @VLAN IDs, and you'll get back the IDs and names. So that allows us to then do this, because we can get back the IDs. So it does get a little bit more complex, as I said, but you'll see later that I automate all this, so you don't have to know anything about OIDs at all. So I'll just give you a very, very quick demo. Hopefully it works. I've just extracted that and everything I've just shown you there. So if I just bring up my screen, just lost my mouse. There we go. Just have to bear with me because it's below me here. So all I've got is a very simple little bash script. This is all integrated into something I'll show you later. You don't have to know any of this. But if you look here, so we first run the query, which will extract all the VLAN IDs and names, which I've shown you. And then what we do is we run this again and just cut out the IDs. And then we've got a loop here, which will feed all the IDs that we've extracted into this other OID. So we're using multiple OIDs here to do something quite simple. So if I just show you, it's not very fancy, it's literally just to show it running. And this port itself isn't in the native VLAN, so this is in VLAN 50. So here we've got back all the VLAN IDs and the VLAN names. So now this is going to feed all those VLAN IDs into this loop script to try and work out what VLAN we're in, because at the moment we don't know. So it cycles through all those numbers we've seen, and if we see here, there's our MAC address, so we know we're in VLAN 50. So it's as simple as that, but you have to use the combination of OIDs to get that working. Okay, back to here. Which is, what is really good is you can extract all the DTP settings for all ports on the switch using read-only SNMP access. So this is the alternative to sniffing, basically. As I mentioned earlier, you might be plugged into port 1 on the switch where DTP is locked down. So your view of the network would say that VLAN hopping is not possible because it's port specific. If you could pull back a list of all DTP modes for all ports, you may find that, say, port 4 on the switch has a default config where you could VLAN hop. So this information is really useful to get back. Quite often on pen tests, there may be several people doing different elements of tests. So one person may be doing an app test, for instance. They might be on port 4, but you're on port 1 doing the VLAN hopping section. So if you've got all this information, it could be the case that if you swap ports with a colleague, you could then VLAN hop. So in many cases, you should have the switch config for complete assurance, but if you don't, this is quite useful. So using the following SNMP OID, you can extract all the DTP modes. So it's a very simple query. It works on any VLAN, again. So the OIDs on the Cisco boxes, I don't know why, but they don't all respond unless you're in the native VLAN. This one does, which is handy. So then we get back the following integer values. So OIDs aren't very human readable, unfortunately. But if we look here, so that's port 1. Didn't mean to do that. Port 1, port 2, port 3, and we get back integer 1, integer 3, integer 2, which isn't that human readable. But what they relate to is the DTP modes. So integer 1 is a trunk port, integer 3, DTP desirable, integer 2, DTP disabled. So integer 2 means it's an access port. So we can improve our first query for DTP modes just using sed, for instance, just to translate them into something a bit more human readable. So if we run the following command, which obviously you can't memorize, it's quite long, you get back all the DTP modes in a lot nicer format. So if you look here, there's 24 ports on the switch, 2 gigabit ports, and we can see the modes of each port here. So for instance, if it was plugged into port 4 here, you wouldn't be able to VLAN hop, but you might have access to port 3, and you would. So it's really useful to have. And that's something you can include in sort of pen test reports. If you pen test for your career, this is probably quite useful for you. If you don't, probably not. I'll just show you a quick demo of getting back the DTP modes. I just need to move my cables. So I've got 6 VLANs set up here just to complicate things a bit. And I just need to, I've just got a little switch data script so I know that it's working. Just put myself into VLAN 1. We should see VLAN 1 come up. Yep, so that's working. Okay, you just have to forgive me because I'm copying and pasting to a screen that's on the floor here, which I can't really see that one. Okay, so just using this following SNMP walk, it's in the default VLAN. So there's our read-only community string. That's our IP address in VLAN 1, and just a straightforward OID. So we get back all the integer values for the ports. If you know what it looks like, then it's quite obvious to me what it looks like. But if you don't do this every day, these are the port numbers, and these are the DTP modes. We can improve this query if we just paste in the SNMP we've said. Just clear that so you can see. So we just paste them on, I had in the slide. We get back that. So again, we've got, it makes it a little bit clearer, the switch ports, access modes, all the DTP settings here. So that's quite useful to have. As I said, it's as good as reviewing the switch config if you get that back. Because as probably most of you know, if you review a switch config for Cisco, if something's on by default, it doesn't usually say. So if it doesn't have it saying off, it's on. So this is a little bit clearer for you. Okay. So that's kind of as far as we can go with read-only access. There's loads more you can do, but this is all about VLAN hopping, so that's kind of as interesting as it gets read-only. The good news is if you have a writable SNMP access, you can VLAN hop, and it gets a lot more interesting. Regardless of the DTP mode of the port, even if DTP is an access port and disabled, you can still make the port a trunk using SNMP. You can also move the port into any single VLAN, as I mentioned earlier. So why would you use SNMP when you can just run a DTP attack? Well, you can also, as I keep saying, you can make any port a trunk or move the VLAN, which is different. DTP, you can only make your own port a trunk. So this is kind of the recommended setting that we give to clients. This port's in VLAN 50. It's an access port, so that's a user port. And it won't be broadcasting any DTP packets. So if you run a DTP attack using sort of Usinia or my Frogger script, it would fail. That would be it. That's it, nothing more. So if we use SNMP, we can basically change that into a trunk or move that VLAN. So where it says 50, we can just change that very simply. There's also a few more complications I found when I was sort of doing this research. Some of the Cisco OIDs on the same device respond differently, so to the actual port number. So port 1 here, this is one OID. So port 1, it could refer it to as port 1, or it could be 1001, and this is on the same device. This is really annoying if you're trying to script something up. So if I'm trying to set something for port 1, one of the OIDs further along, which I'll use in the script, has to be 1001. So I've had to factor all these sort of things in for compatibility. It seems to vary between switches and iOS versions. I've got about half a dozen switches, and this works on all of those now. Before it didn't. Like everything, it gets a bit sort of complicated as you go along. So using SNMP writable community, you can change the DTP settings to anything you wish. So the example, if you're looking at the port configuration shown, typical DTP attacks will not work on this. So it's an access port, it's non-negotiate, so there's no DTP packets. So if you packet sniffed, you won't see any DTP. If you try like a Yesenia attack, it won't work. So using the SNMP query shown, so again, it's a writable community string, just using SNMP set, very simple, built into Kali, whatever. IP address of VLAN 50. So this is the OID we use. 23 refers to the port number. Depending on the model of the switch, that could be 10023. And integer 1 is the DTP mode. So we can change this to anything we wish. So we could make it an access port, but that already is one, and that's not interesting. So integer 1 means make it a trunk. So if we run that one query, it simply just changes it into a trunk straight away. So it's an access port, now it's a trunk. Even though it still says VLAN 50, you'll see all VLANs on that port just running that one command. So if you run, this is just a Wireshark after I've done the attack on port 50, and you'll see I can see VLAN 44 in the tag packets, just to show you that works. So again, I'll just show you a quick demo. I don't need to move cables. So this will show exactly what I've just shown on the slides. If I can get my screen up. Demo 3. So if I've got a console connection into the switch here. So I'll just show you the switch first. So I'm going to change interface 1. So this is live on the switch here. So this is an access port, non-negotiate. DTP attacks will not work on this port. And if I just show you the trunks for this port, just clear that screen. Like this. So this is port 1, so you'll see it's off, so it means it's an access port. It would be set to auto if it was default. Non-trunking, and the VLANs allowed on that port is just VLAN 1, so it's completely default port. So if I paste in this SNMP set command into the screen here, so this is exactly what's on the slide. Writable community string. This is the OID. And on this switch, as I said, you've got to refer to it as 1001, even though it's 1. Integer 1, so I'm saying make this port a trunk. We should then get a timeout, because the port will basically drop. Okay, and hopefully, fingers crossed, there we go. It's now a trunk port. There. And if I just view the trunks, so it's now on, it's now trunking. We've got all VLANs on that switch, just from running that one command. Okay. Unlike normal DTP attacks, using SNMP, we can also move it into another VLAN. So rather than just making it a trunk, we can just flip it into a different VLAN. So in the example here, again, it's a port where DTP's attacks wouldn't work. I must stop clicking on that. It's an access port, and it's in VLAN 50. So there is a VLAN 44 con VLAN, VLAN 44, strangely enough, and we want to move into this port. So again, we have to use a different OID in this case because we're not changing DTP settings, we're actually changing the VLAN ID. There's tons and tons of OIDs, but I've gone through them all to pick out ones that are useful. So if we run this command here, again, writable community string, this is VLAN 50, there's the OID, 23 is the port number, 44 is the integer for the VLAN ID. So it can't be a name, it needs to be the ID. So this can be anything, obviously it must exist. And it simply changes this to VLAN 44. So where that was VLAN 50. The advantage of this is we've not made it a trunk port, It's still an access port, and it's pretty straightforward. So we haven't had to alter any DTP settings whatsoever on this. We've simply just changed VLANs. So I'll just show you a quick demo of that as well. Let's move cables. Sorry, I could use my mouse. So if I show you, this is changing port 3. So I'll just clear that. So it's just showing the config for port 3. Again, that's an access port. It's not in any, this is the native VLAN 1, because we're not specified a VLAN. So again, DTP attacks won't work there. If I paste in an SNMP set command into here, let's just clear that. Again, writable community, exactly what's in the slide. On this one, it's 1003 again, and then 44. We'll get a timeout again. Okay. So we can see above, before the previous command, if I can get my mouse there, there we go. So if I just show that port again, you'll now see it's an access port in VLAN 44. So great, that worked. Okay, so you didn't have to remember all this boring OIDs and complications. I've put this all into my new script. Those of you may have used Frogger before. This is Frogger 2, strange enough, but it's a complete new version. I've basically rewritten it from the ground up. I've put tons of work into this. It's just a bash script, that's all I know. I'm not a programmer, but it started off as a one-liner, which turned into 400 lines for Frogger 1. Frogger 2's got 1,400. So there's a lot more functionality into it. And it's purely for VLAN attacks. It's not something you do every day. So when you come around to it, rather than pulling out your notes, you can just run this. So there's a lot of new features for extracting information, for attacking, for doing passive attacks, and all the SNMP, just move my mouse, everything SNMP related I've shown you is built in. You can also run an SNMP extract, so if you don't want to attack anything. So I'll go over a few of the new features. If you've used the old, I won't demo any DTP attacks, because it's quite old school now. I'll just show you the new features. I've released this last night, so silently it's on my GitHub, so I've replaced the existing version for the version 2. So you can all download it as of now, or at least after the talk, hopefully. You won't all rush out of the room. So I've added a DTP scan into this. So this doesn't have anything to do with SNMP, although it's an SNMP talk. This is really useful. So it's a passive detection tool built into Frogger 2. So quite often there'll be a scope, can you VLAN hop, and they'll just perhaps run Frogger and attack the switch, which isn't always the best way of doing it. So this will tell you the mode by sniffing packets of what the switch is configured on that specific port, and it will tell you the likelihood of that working. So you could then go back to the client and say, are you happy for us to run the attack? So it's completely passive. It's really useful. So what this does is you don't need an IP address. It's totally passive, as I said. It works at layer 2, so it simply just sniffs in the background for DTP packets. And it will translate them into human-readable formats. So it will basically tell you the likelihood of the attack working. So here you'll see DTP is found enabled, VLAN hopping will be possible, and that is accurate. So it's translating the hex code it sees into the different modes, and there's lots of modes. Well, there's 5 modes, but there's lots of different hex codes for some reason. I don't know why, on different switches. But what you have to remember is it's port specific. So if you run this on port 4, and it says you can't, port 5, maybe. So you'd have to run it on every single port. So if I just show you a quick demo of that, I'll move cables again. So you've got a nice new menu and also a picture of a frog, which is useful. So option 1, DTP scan. It will also tell you here if it's passive or an active attack. And the most common option here was the old version of Frogger. So it does the straightforward DTP stuff. I won't show you that today, because most of you have seen that. So if I just do option 1, it'll ask us what interface we want to scan from. So in this case, it's Ethernet 1. And unfortunately for the demo, it will take 60 seconds. I could have reduced this, but DTP on Cisco switches broadcasts every 60 seconds. So if I set it to 30 and missed it, I'd have to do it again. But what I've built into the new Frogger version is if you run a scan, you can customize the times in the top of the script. If you run a scan that doesn't find anything, it will then say, do you want to extend the scan? And it will add 30 seconds to it. So you don't have to keep running the whole thing again. So this is simply sniffing at layer 2. I've got no IP address on this VLAN. So if you're sitting just on an office desk, you could run this, and it will tell you if you could VLAN hop. Quite often you can, which is still quite scary. So you could be on the corporate network and access something quite sensitive. Just let that finish. Hopefully this works as well. There we go, that worked. So if I get my mouse. So if you see here, D2 was found enabled in auto mode. So this means that someone hasn't gone onto switch and set it into an access port. So if you, almost all Cisco switches out of the box will be set to this. And it will tell you VLAN hopping is possible. So you could now run an actual DTP attack if you wanted. This has nothing to do with SNMP, but I thought I'd show you it because it's quite useful on tests. Certain clients won't like you attacking things. So you can go back to them and just say, there you go. And you can put a nice little screenshot in your report. Okay. So all the SNMP hopping and extraction I've added into Frogger 2. So you can change your own port, any other port, and then you have a choice. Do you want to make it a trunk port, or do you want to move to another VLAN? It's all very menu-driven. Intro 1 and 2 can't get much simpler than that. You don't have to memorize OIDs. That's my task, unfortunately. So if I just show you a quick demo of that one. Okay, I'm in the right cable. So I'll first show you the config from the switch. So this is the console cable on the switch again. So it's on port 5 I'm attacking this time. So that's the default port. This is the port that we've just run the DTP scan on. So you see they've not specified to make it an access port. So this is out of the box config, so you can VLAN hop. I don't know why they ship them like that, but they do. And if I just show you there's no trunks on the port as well. So again, not trunking, VLAN's allowed on the port 1. So if I run Frogger 2, and what I'm going to do is make my own port a trunk using SNMP. So we'll just clear this. So option 4, SNMP VLAN hopping. So it will ask you for the IP address. So this isn't, you have to be able to talk to the device on SNMP. And ask for the community string as well. So in this case, it's private. That's a writable string. If you put in public, even though you're doing the attack, which I'll show you later, it will know that. It works out if it's writable, and it will just extract. So it just verifies, very simply, just using mmap, is SNMP open. Then it works out if it's writable or not, which it does here. So first of all, what it will do is extract all the VLAN IDs and names, which was the first demo I showed you. It's just got some nice colors now. So it knows there's 25 VLANs on the switch. Here's all our VLAN IDs and names. It knows that we're in port 5 on the device. You'd be amazed how hard it is to work that out. It's very hard. And it tells you in the default VLAN 1. So now it gives us some options. Do we want to attack our own port 5, or do we want to attack another port? So in this case, I'll just say I want to attack my port. We get another option. Do we want to make it a trunk? So we do want all VLAN IDs, or do we just want to move it? In this case, I want all VLANs. So I'll just make it a trunk port. So this enables the trunk through SNMP. So I've added in a thing which sleeps for 25 seconds. The reason is due to things like spanning tree. So when you change the port into a trunk, the port will drop. It's like unplugging the cable and plugging it in again. So I've added a little timer. If you don't have something like port fast enabled, which I have on my switch, it will take a little while. And then it asks us if we want to scan. So we don't have to do this, but this is like the original Frogger. So if we give it the interface of my laptop connected, what it will do is it will just sniff now for DTP packets. Because we've made it a trunk, this port should now have all the VLAN IDs on that port. So it's just simply sniffing in the background. You don't have to do this. While it's doing that, if I show you back on the switch, so we look at port 5 again, you'll now see that's a trunk port. So we've done that just using SNMP. And you can see we've got all VLANs. So we should, from Frogger, get back all those VLAN IDs that it sees on the port. It's not extracting them from SNMP, it's sniffing them on your port. So if it sees the ID, it will list it. There we go. So your port's got access to these VLANs. So you can see here, VLAN 44. So we could now just connect to that if we wished. Okay, lost my mouse again. There we go. So the advantage of using SNMP, as I keep saying, is you can alter any port. It doesn't have to be the one you're connected to. So I can make any other port a trunk or change the VLAN ID. So what I'll do is show you altering the VLAN ID on another port. In this case, it's port 6, but I will be plugged into port 23. So on DTP, you can't do this on a traditional DTP attack. In this case, though, I will be in VLAN 50, so I just need to change my script. So I've just got a few little scripts, so I don't have to type everything. This is just setting up my IP for this interface. We see VLAN 50's up. Okay. So we're in port 23. If I show you the config for port 6, let's clear that. So this is in VLAN 50 at present, and it's an access port. So like before, DTP wouldn't work here. So if I run Frogger 2, so an SNMP attack, in this case it's 50, because it's VLAN 50, private. What this should do is work out we're now not in the native VLAN, and it will have to then cycle through. So like the first demo where it finds your MAC address, this will automatically do this in a sort of prettier way, so you don't have to do it. So you can see here it's worked out already. So it's got your VLAN IDs, but it says it seems you're not in VLAN 1. And it will need to run 25 queries because there's 25 VLANs. So it will just go through, are you 44, are you 50? And then it will come back and work out what port you're in. So this was the original complication that I've got round. Just takes a few seconds. So it knows we're now in VLAN 50. And we're in port 23. So what we want to do is attack another port on the device, which is option 2. Enter a single VLAN ID, so option 2. So rather than making it a trunk this time. And it will list all the ports on the switch. If you put the wrong port in, it will just say do it again. So it's 1006. So here we just enter the VLAN ID. So we're in VLAN 50. If we want to go into VLAN 44, let's put in 44. So it'll now tell you you're in VLAN 44 here, port 6. Remember, we're in port 23 ourselves. So we're now in VLAN 44. So, and if you look, it's not a trunk port. It's still an access port. So we haven't made it a trunk. The reason you do this is sometimes they may say there's sensitive VLANs that are completely out of scope, and that if the goal of the test is from VLAN 50, can you get to 44? That's what you do. It's done. Okay. So this is the last demo now. So I'm going to change my own port VLAN ID manually using SNMP. So our goal is to get into the 44 con secure VLAN here. I'll show you first, just running it read-only in attack mode, just so you can see it actually works out that you haven't got writable access. So if you thought you did, this will tell you haven't. So this is in VLAN 1. Okay, just make sure I can see it. Sorry, just bear with me a second. Okay, so it's an SNMP attack, option 4. I'll do it in VLAN 1 so you don't have to cycle through all the VLANs. So if I thought that public was writable, they don't have to be public and private. So they don't also have to be default, they can just be weak SNMP strings. So I put in public thinking this is writable. It will test it to see. So it tells you here, like, hang about, that's read only. And then it tells you you're not going to be able to VLAN hop here, even though you thought you could. But what it will automatically do is dump out everything it can, which is quite useful. So it gives you all the VLAN IDs and names, tells you how many VLANs there are, tells you in port 21, tells you in VLAN 1, and it gives you all the DTP settings. And that's as much as you can do, so it knows that out of the box, so you don't have to do that. Okay, so if I show you this. So I am going to attack port 21. Which is the wrong port. Okay, so there's port 21 config. This is one I'm plugged into now. It's an access port. So it's in VLAN 1. I want to jump into VLAN 44. So if I run Frogger, option 4. You see that? Yeah. Put in the IP address. Put in private for the community string, which is writable. So we'll go through the same steps again. But I'm going to attack my local port this time using SNMP. Okay, so option 1, attack my own port 21. And option 2, and so I'm not going to make this a trunk, I just want to go into VLAN 44 from VLAN 1. So again, 44. It just sleeps for a brief second just so the change applies. Okay, so it tells you there. It is making a bit of an assumption there. It doesn't verify that, so you need to check. If I just look back on the switch, if I find my mouse, there it is. If we look at if you look above was the old port 21. We can now see it's in VLAN 44. So if I go back to my terminal here, so I can just jump out. If I just set myself up an IP address for VLAN 44, and that's just automated. I'm not doing any fancy separate VLAN interfaces here. It's just setting an IP address. So I can now, hopefully, connect to the 44 log. There we go. So this is the secure VLAN. This is the Cisco router in the 44-con VLAN. So I've jumped from VLAN 1 into 44. So this is not a trunk port. Didn't use DTP. There's the Cisco switch. Okay. So that's the last demo. Luckily, they all worked. So just to wrap up and recap on what I've gone through, there's a lot of technical bits there. So for VLAN hopping using SNMP, you must have a writable community string. If you haven't, you can't do it. It's just an extra feature. It's not something you'll see every day. If you do, then you can do it. If you've got read-only access, then you can extract all the VLAN information and the DTP modes. DTP scan is really good. Well, I think so. Where you can check if a traditional DTP attack will work. So this will just sniff the passive modes for you as I've shown. This is all built into the tool. So Frogger 2 is out now. You can use this. It will fully automate everything. You don't have to know anything about OIDs or SNMP. You just need an IP address and working community string. And it includes all the traditional DTP attacks, which have all been improved. There's CDP extraction. There's VLAN attacks where you don't need CDP enabled. All Cisco bits, really. So that's really all I have to cover. Hopefully most of you aren't asleep, but if you've got any questions, yep.